Assalamu alaikum dear students. Today we are going to solve this paper 1, which is the MCQs 5070, and this is the 1-1 paper variant, and May June 2022. This is the recent one, and the time given for this paper is 1 hour. So let's go towards its first question. A scientist needs to add approximately 100 cm cube of water, 100 cm cube of water, okay, to each of 50 large beakers. To each of 50 large beakers means the beaker which have the capacity of 50 cm cube. So what he has to do, he has to make 100 cm cube of the water. So a scientist needs to fill the beakers as quickly as possible. Definitely he has to take care of the accuracy, and he has to do this task quickly. So which method should be used? 50 cm cube burette, which should be used twice for each beaker. No, burette is for more accuracy, okay, but it takes time. It cannot be used quickly, okay, so it seems inaccurate. So 100 cm cube gas range is for gas, not for the liquid. Water is the liquid. 25 cm cube graduated pipette, but it will has to be used 4 times, okay, for each beaker which contains the 50 cm cube. So we will fill the pipette twice to fill the one large. No doubt it is the accurate quantity, but it will take time, okay. So 100 cm cube measuring cylinder should be used once for each beaker. Yes, this is the good answer, that if we have 100 cm cube measuring cylinder, so it has capacity till 100, and we can use it for 50, okay, measuring cylinder. So once for one beaker and the second time for other beaker. So option D is correct. For mixture each containing 2 substances are shown in the table. The 2 substances need to be separated and collected: copper sulfate and water. So one is the liquid and one is a solid, so chromatography cannot separate them, okay. If we use any type of the solvent, so aqueous solution will move upward, okay. So aqueous contains, if the copper sulfate is going as aqueous upward, so moving upward, so it means it is also taking water, so it cannot be separated by chromatography. Methanol and ethanol, so their boiling points are very close, okay. We cannot evaporate one of them. If one of them is the solid and other is the liquid, so we can evaporate, okay. So liquid will be evaporated and solid will be left, but both are the liquids over here, so we cannot separate by the evaporation, okay. Both will evaporate, so both cannot be separated in this way. Oxygen and nitrogen by the fractional distillation. Yes, fractional distillation is the separation of something on the basis of boiling point. You understand it, okay. So oxygen and nitrogen both are the gases which have different boiling points, so that's why they can be separated when they will be cooled. So on their different boiling points, they will become the liquid from the gas to liquids, okay. Sand and barium sulfate by the filtration. No, both are the solids. How can they be filtered by the filtration, okay. And both are insoluble solids. We cannot even dissolve in the water to make them soluble, okay. Barium sulfate is also insoluble, okay, so it cannot be separated by filtration. 2 samples of colorless solution are tested separately with the aqueous sodium hydroxide and the aqueous ammonia, and the results are recorded. A white precipitate is formed with 2 drops of NaOH. Okay, it can be barium, it can be aluminium, it can be, there are different things, okay. But let me tell you, this precipitate dissolves when excess of NaOH. When something white precipitate is there with something in when a few drops are added of NaOH, but in excess when it dissolves, so definitely it is zinc. You would have memorized from the table given in your book. The same happens with the NH3. That white precipitate are formed when 2 drops of NH3, and this dissolves when excess of NH3 is added. So this is not chloride, because it forms the white precipitate when there is AgNO3, okay, silver nitrate. So it forms a AgCl, so then it is white precipitate, okay. So it can never be. And cations present is Al3, but it when excess is added, so it does not dissolve, okay. So it is also not present, so only option D is correct, that is the zinc. Which row correctly describes the changes in the particles when this substance freezes? So when the freezes, so let me tell you, become less hardened or more hardened? They become more hardened, not less hardened. Okay, this is done. Means when those are moving randomly, so when those are frozen, so they become hardened and they become in a regular pattern. Okay, and they lose their energy, not they gain energy, because on freezing, when something is being frozen, so their energy, their kinetic energy is being lost. Okay, so option B is correct. Okay, they don't gain energy, they lose energy. Okay, okay, this is a typical question related to the diffusion. You understand, ethylamine and the hydrogen chloride HCl react together to form the white solid. Its name is ethylamine hydrochloride. Okay, what do you don't need to worry about the formula of the solid. Okay, just you need to focus on their formulas and their relative molecular masses, because you understand the rate of diffusion is inversely proportional to the molecular masses. Okay, greater the mass, less the diffusion. Lesser the mass, greater the diffusion. Okay, so let me tell you their masses. For 2 carbon 24, for 5 hydrogen 5, for nitrogen 14, for 2 hydrogen 2, so it becomes 38 and 40 and 45. This becomes 45. Okay, and you know that 1 and 35.5 for chlorine, it becomes 36.5. So it has less mass, definitely it has to travel more. So you can see over here, if you would have scale, when you will be solving, you will find that B is the middle, is the mid. Okay, but you must know that hydrochloric acid, and second is ethylamine. Okay, C2H5 ethyl and amine NH2. Okay, it will travel more. So this is a mid, so definitely it will travel more till here, and it will travel less because it has a more mass, so it will travel less. It has less mass, it will travel more, so here the white crystal will be formed. Option A is correct. Okay, two particles have the symbols. You can see the symbols over here. So which statement about these particles is correct? You know that they contain same number of electrons. Let me tell you about the electrons. 26 protons are there, so 26 electrons have to be there. But here plus 2 shows that 2 electrons have been lost, so it becomes 24. Okay, is it clear? Now second, it has 27 protons, so 27 electrons has to be there. 3 charge shows that 3 electrons have been lost, so it becomes 24. So it means same number of electrons. This is the correct answer. We don't need to worry about other things. Same number of neutrons. Okay, man, this is correct, so don't need to worry about it. Okay, the others cannot be correct. Okay, two isotopes of chlorine, one is 35 and one is 37. You know there are two types of the isotopes of the chlorine. So using these isotopes, carbon 12, hydrogen 1, means the isotopes of the carbon and hydrogen are the same. Okay, they don't vary. Okay, so how many different relative molecular masses are possible? Okay, so how many possibilities are there if we have this? So we have 3 chlorine. 3 chlorine can be of okay, let me tell you, chlorine can be of 35. 3 chlorine can be of 37. 3 chlorine can be of 1 chlorine can be of 37 and 2 of 35. And when we have 3 chlorine, so what can be possible? 1 chlorine of 35 and 2 of 37. So it means but other things will not vary, means the carbon and hydrogen. Okay, so it means 4 isotopes, 4 different masses are possible. Which statement about the substance at the room temperature and pressure is correct? W and X conduct electricity at room temperature, okay, and pressure. So at the room temperature, you know, this is some type of you can say metal and non-metal. Okay, so you can say this is the allotrope. This is ionic compound. This is something you can see, this is diamond. Okay, because you can see its shape. Okay, it is tetrahedral, something like tetrahedral and no free electrons. And Z, as you can see, that this is the ethanol C2H5OH. Okay, so W and X conduct electricity? No, W cannot, and X also cannot conduct electricity at the room temperature. Okay, wrong. W and Y are elements. W is not element. It is a mixture of different elements. Okay, Y can be element. It can be carbon, but W cannot be. X and Z dissolve in water. X is ionic compound. It can, and this is lithium chloride. Okay, it is soluble in water. Okay, and Z is a, yes, this is also, you can say it has partial negative charge because of electronegativity difference. It has partial plus charge, so it's possible that it can dissolve, to some extent. Alcohol is soluble in water, that ethanol is soluble in water, so C is correct option. The Y and Z have low melting point. Why? How? It has very high melting point, that diamond is very high, so it's also incorrect. Okay, let's move to the next question. A piece of magnesium reacts with the hydrochloric acid. Okay, so a resulting solution is then evaporated, leaving a solid residue of magnesium chloride. Which statement is correct? The covalent solid is formed in this process. No. Let me tell you, magnesium when reacts with the hydrochloric acid ICl, so what will happen? MgCl2 will be formed. Okay. You know why MgCl2? You know that Mg has plus 2 charge and Cl has minus charge by cross exchange method 1 and 2. So you will have to take Mg and Cl2, okay, to make the charges equal. So we'll have to take here twice, so plus hydrogen will be left. Okay, so this is metal and non-metal. Okay, this is the ionic compound. Is it clear? The covalent solid is formed in this process. No, not covalent solid. When both are reacted, okay, this is dilute. Okay, so it's aqueous, sorry, this is aqueous, let me write aqueous. Okay, so it's aqueous will be formed and this gas will be released. Okay, now when it is evaporated, so magnesium chloride will be left, okay, as a solid. A covalent solid is found in this process. This is not covalent solid, this is the ionic solid. Each chlorine atom gains one electron in this process. Each chlorine atom gains one electron in this process. This is each chlorine atom gains one electron in this process. Yes, this is also possible. Okay, each chlorine atom. Let me tell you one more thing. Each magnesium atom loses only one electron. No, each magnesium loses two electrons. Molecules of an element are formed during this reaction. Molecules of an element. No, molecules are not elements. Molecules of compounds are formed. So this is the correct option. Which dot and cross diagram represent carbon dioxide? Let me tell you, carbon has 4 electrons, so cross are 4, it's okay. Oxygen has how many electrons? 6. 2 to 4 to 6, and this is the 7th one. Wrong. Carbon has 4, but here carbon only cross of the carbon are 3, okay. Wrong. Carbon has 4, it's okay. 4 crosses are there, it's okay. Oxygen has 6, you know that oxygen has 8 and 2 and 6. Outermost has a 6 which take part in the bonding. Okay, this is the valence electrons. And carbon, you know that it has 6, so 2 and 4. So 4 are shared and here 2 are shared. Okay, and 4 remains outside. 4 are outside, 2 are being shared. In this way their octet is completed, and 2 are outside and 2 are being shared. So this seems the correct option. Here only 2 electrons of carbon are shown. This is also incorrect. Next question. Two statements about the structure and the properties of metals are given. Metals are malleable and have the high melting points. That's okay. Metals have mobile electrons in their structure. That's also okay. It is correct. Both statements are correct. And statement 2 explain the statement 1. Okay. Both statements are correct and statement 2 does not explain statement 1. Statement 2 does not explain statement 1. Yes, we can say like this, that malleable is something different and high melting point. This can be of different reasons. Okay, metals have mobile electrons, so due to mobile electrons they can have metallic bond. This can be the reason. They conduct electricity. This could be the reason. They explain only statement 2 can explain that they have the metallic bond and they have the they can conduct electricity. This thing can be explained by the statement 2. But the statement 1 cannot be explained by statement 2. Okay, so I think option B is correct. Okay, how many different elements are present in the aluminium nitrate? Aluminium and nitrate, NO3 thrice. Okay, one type, second type, and three. So three types of elements are there. Okay, question number 13. Aqueous calcium hydroxide is an alkali. Okay, calcium hydroxide, OH twice. It neutralized by nitric acid plus HNO3. To produce calcium nitrate and water, let's see calcium nitrate how it is produced. CaNO3 twice plus 2H2O. To balance it, let me write over here 2. Okay, this is aqueous. So ionic equation for this. This is this is the liquid covalent, so it will not convert into ions. Okay, both are aqueous, so let me tell you, Ca plus 2 will be formed and plus 2OH minus will be formed, plus 2H plus will be formed. I'm not writing here aqueous, but you will have to write aqueous. Okay, I also write over here, and plus 2 nitrate to NO3 minus aqueous. Okay, so what will be left over? Ca plus 2 and NO3 to NO3 minus, this is aqueous, and this will not convert into, it will remain as it is, 2H2O. Now you can see over here the same charge will be cancelled, calcium with the calcium and 2 nitrate with the 2 nitrate. So what is left? 2OH minus aqueous plus 2H plus aqueous give rise to 2H2O liquid. If there is something like this, we can call it ionic equation for this. What is the ionic equation? This is the full equation. Okay, not possible. Calcium has been cancelled. Okay, it's not available over here. This is the answer. Okay, ionic equation. Actually, they have summarized it. No problem. But ionic equation is this one. Okay. D. Question number 14. The relative molecular mass is 60. It contains carbon 40%, hydrogen 6.7%, and oxygen. Okay, we show correct empirical molecular formula. Let me tell you, carbon is 40% and 6.70% is hydrogen and 53.3% is oxygen. Let's divide them by their atomic masses to find their moles. Okay, so let me take out calculator. Okay, it's taking a bit time, but you should also have calculator on the spot, because when there comes any calculation related to stoichiometry, you'll be solving it easily. 3.33. Okay, so what's next? 6.70. okay, this is as it is, 6.70. 53.3 divided by 16, 3.33. Now let's divide with the least. The minimum is the same, 3.33, 3.33, 3.33. This is one time. This will be almost two times. Okay, 66 it becomes, so two times, one time. So CH2O is the empirical formula. CH2O, it's confirmed that this can never be the empirical formula. Okay, now what's the empirical formula mass? Carbon is 12, for 2 hydrogen is 2, and for oxygen is 16, so it becomes 18 and this becomes 30. So you know that N is equal to molecular formula mass over empirical formula mass. So molecular formula mass is 60 or empirical formula mass is 30, so it becomes N is equal to 2. So we can find out the molecular formula by multiplying N with the empirical formula. So you know that you have empirical formula CH2O multiplied by 2, so C2H4O2. This is the molecular formula which has the mass 60. Okay, C2H4O2. Option B is correct. Okay, we can take help because always the ratio of the empirical formula mass and molecular formula mass is the same as their ratios in their formulas. Okay, how many tons of aluminum oxide are required to produce 27 tons of the aluminum? Okay, let me write over here. Aluminum oxide Al2O3. Okay, let me write balance equation because we'll have to write O2. So what is produced? Aluminum is produced plus oxygen is produced. Okay, so I'm writing here 2, so 4 aluminum and 3 O2 will be produced. Ratio is the same, no problem. Okay, so we can take the mass to mass ratio over here as well. Okay, we know that the mass of the aluminum is 27, done, multiply 2 plus for 3 oxygen is 48, 60 multiplied 3. Okay, 54 plus 48, how much it becomes? 2, 1 carry 10. Okay, this is the answer, 102. Multiply 2 because 2 moles are there, so 204. And how many is being produced over here? 27 multiply 4, it becomes 108. Sorry for inconvenience, I have a bit coughing. I've got cough. So how many tons of aluminum produced are required to produce 27 tons of aluminum? So if we have 27, so x. Now let's solve it. 27 multiplied 204 is equal to 108x, and x is equal to 27 multiplied 204 divided by 108. When you have calculator you can do it easily. I'll have to take it out. 27 multiplied by 204 divided by 108. Sorry, 27 multiplied by 204 and divided by 108, so 51. Is there any option like 51? Yeah, of course. So if you have 51 tons of aluminum oxide, so you will get 27 tons of aluminum. Okay, this is the mass to mass ratio, but from the balanced chemical equation. Okay, and why we had to take it twice? Because we cannot take it, we cannot write 3 atomic oxygen and we'll have to write here O2, so then taking 1 by 5 is a bit strange, it's not favored, so that's why I took it twice. So when I've taken it twice, so everything increased by the same ratio. Okay, it was going to be 2Al and now it has become 4Al, so no problem. Okay, ratio remains same in the balanced chemical equation. So we have lead bromide is electrolyzed by inert electrodes. Inert electrodes means which will not react. Okay, so we have lead bromide, Pb Br2 I'm writing here. Okay, so Pb plus 2 and 2Br minus. Which statement is correct? A brown gas is seen at the positive electrode, so it will move towards the positive electrode, so its color is definitely brown. Okay, so what will happen? Brown gas will be formed, Br2 plus 2 electrons will be lost. Yeah, at the anode it happens. Okay, loss of electrons is called oxidation. Okay, oxidation takes place over here. This seems correct. Okay, let me see the other options as well. Okay, electron passes through the solution from one electrode to another. Electrons passes through the solution from one electrode to another. No, in this case it never happens because lead is moving towards the cathode and it will not let the pass, it will not allow the electrons to pass through it. Okay, it will be, so this is not. Ions passes through the circuit from one electrode to another. No, in the circuit ions cannot move. Lead oxide is oxidized. No, not at all. So it means option A is correct. Okay, it means bromine is released over here as gas. Okay, and its color is of course brown. Okay, compound X is sodium iodide. You can see compound Y is methyl methanoate. At room temperature and pressure, A, sorry, first one solid, and in aqueous solution to electricity. Okay, which word correctly complete gaps 1 and 2? Okay, compound X is sodium iodide. Okay, at sodium iodide, when it is ionic compound at room temperature and pressure, one solid. So actually, sodium iodide has to be solid. Okay, you must know. Okay, methyl methanoate. This is ester, and this has to be liquid. Okay, okay, this has to be liquid. And in aqueous solution, definitely it conducts electricity because this is not conductor of electricity. Methyl methanoate. You will see carbon, double bond oxygen, oxygen, and CH3. Its aqueous solution is not formed even because this is the non-polar totally. Okay, it is soluble in the organic solvent, so that's why it, and even it does not have like free electrons or ions to move. Okay, even it is not dissolved, so only aqueous solution of this is formed. And it's only aqueous solution of X means, I mean to say that. Okay, so option D is correct. Only X is solid at room temperature, and aqueous solution only X conducts electricity because it is the ionic compound. So when its aqueous solution is formed, so it has free moving cations and anions which conduct electricity. Okay, so option D is correct. You can see other options as well. For the forward reaction of the reversible reaction, the enthalpy change of the reaction is minus 50. What it means? It means there is reactants and then there is products. So enthalpy change for the forward reaction is minus 50. It means release of electron. So it is exothermic. Okay, minus shows release of energy. Okay, this is exothermic reaction. So, and the activation energy is plus 60. What is the activation energy of the reverse reactions? Okay, reactants is here and product is here. So difference between the reactants and the product is sorry, reactant has to come here, is minus 50, and activation energy is also 60. Okay, so after crossing this barrier, this is compensated, the gain of energy and loss of energy, but here this is the loss. Okay, actually this is enthalpy change. Okay, so what is the activation energy of the reverse reaction? Of course 110, but it will be plus or minus. It will be plus because it has to be added, means when the products has to change, so from products to reactants, so it will have to be use energy, it needs energy to cross this barrier. Okay, so this is the 50 of this, which is the difference, okay, of the reactants and products, and 60 of the activation energy. So uh, all of this has to be required to the reactants to become product. Okay, to the products to become reactants. Okay, so plus 110 kilojoule per mole it has to be given, and when something is added and energy is ended, so it is endothermic, and endothermic is always plus. The diagram shows the titration experiment. You can see over here a titration experiment. Okay, let me minimize a bit. Yeah, of course. So this is the acid and this is the alkali, which show the reaction is conical flask is correct. It is exothermic, of course. The reaction of acid and base is exothermic, not endothermic. Okay, and the sign will be negative. To show the exothermic, it has to be negative, not the positive. Okay. Question number 20. Sulfur dioxide reacts with oxygen in the air. You can see the reaction. The reaction is very slow if no catalyst is present. Okay, which catalyst is used? Do you know this thing? Just for your information, I'm going to tell you vanadium pentoxide V2O5. Okay, okay. So the reaction is very slow if the no catalyst is present. This statement explains this. Air contains only 21% oxygen, so there is not enough oxygen for all the sulfur dioxide to react. No, this can never be the statement. Okay. Only a small proportion of the sulfur dioxide and oxygen molecule have enough energy to react at high temperature. Yes, this is a possibility that only a small amount of the sulfur dioxide and oxygen will be able to react to form the sulfur trioxide. Okay, now let's see the reaction is exothermic. So at high temperature, the equilibrium shifts to the left. No, it's exothermic. So at high temperature, it will have to move to the right, not left, because it's already releasing energy over here when moving from far to when moving towards the left. Okay, from right to left. So it is releasing its exo. So increase in temperature will not favor, will decrease it and will favor the reverse reaction. Okay, so option is correct. The reaction is reversible, so the products turn back to the reactant. This happens very quickly at high temperature. No, at high temperature even they do not come here. Okay, the products are not even formed. Okay, reversible, so products turn back to the reactants. This happens more quickly at high temperature. This can be option, but this has no concern with with this. The reaction is very slow if the no catalyst is present. Okay, so actually it has no concern. Option B is correct. Small proportion of sulfur dioxide and oxygen molecule have the enough energy even at high temperature. Okay. Which statement is correct? An enzyme is biological catalyst and decrease activation energy of the reaction. Of course. When normal reaction is there, so there is a high barrier. When enzyme is there, the barrier is reduced, and this is the biological catalyst. Okay, so option A is going to be correct. And when A is correct, and we are sure 100% that A is correct. So biological catalyst and increase activation energy, wrong. Enzyme is compound of transition, not compound. It's biological catalyst. Okay, not transition elements that decrease activation energy. Is compound of transition element that increase. No, it's not necessarily that compound of transition element. It can have different structures. Okay, it is sorry. It is proteins. Well, enzyme is proteins, globular protein. Okay, it's not compound of transition elements. It's proteins. Okay. Question number 22. Nitrogen dioxide is dark brown gas that decompose as shown in equation. The diagram shows a glass flask containing a mixture of three gases. The mixture is pale brown. Okay, you can see dark brown to NO2 decompose into nitrogen dioxide into nitrogen monoxide and the oxygen gas. Both are colorless, and this is dark brown. More oxygen is forced uh, into the flask. Which color change is seen in the mixture? It becomes a darker brown. Yeah, of course. The reason is mixture is at equilibrium. Okay, you can see 2NO2 and it gives 2NO plus O2. This also gas. This is gas. It's also gas. So the diagram shows the flask contains a mixture of three gases. The mixture is pale brown. More oxygen forced into the flask. If more oxygen is forced, so what will happen? The concentration of the products is increased. So reaction will move towards the. It was at the dynamic equilibrium. Now it will move towards the right. So it is already dark brown. It will become darker brown. Okay, means more nitrogen dioxide will be produced because of the more concentration. You know that its concentration was less. Okay, now its concentration has been increased. So due to high concentration, according to Chetlier principle, as I told you, so it will move from the higher concentration to the lower concentration. Okay, like this. So dynamic equilibrium will be disturbed and can be re-achieved, can be re-established, but now equilibrium will move towards the right from the more concentration to less. Okay, so they are in higher concentration, so they will react to form the more nitrogen dioxide, so it will become more darker brown. Okay, consider hydrochloric acid oxidized by manganese oxide, manganese 4 oxide. Okay, so what are two products of this reaction? Mangan. What happens over here? Concentrated hydrochloric acid (HCl) is oxidized by manganese oxide. I'm taking it over here like this. This is 4. Okay. Is oxidized. I'm taking here 2 because it has plus 4 over here, but it will become plus 2. Means itself it will be reduced, so it will oxidize it there. Okay. So MnCl2 plus H2 plus O2 or H2O2. Simply you can say whatever happens, but what are two products of this reaction? So two products, manganese has plus 2 charge. Okay, and the chloride it has minus. Okay, sorry, this can be Cl2. Okay, so this will be formed. Okay, this can be like this, so that it can be different. Okay, its equation can be different, but the option B is correct because and two chloride will be found. Okay, it will not react with the chloride. Okay, the table gives the information about the four redox stations. You can see over here the redox station. Redox means in which the oxidation and reduction both take place together. Okay, which row gives the correct information about the what is oxidized and the evidence that this is oxidation. You can see over here that equation copper oxide and the carbon has converted into carbon monoxide, so it has gained oxygen, so oxidized, and it has lost oxygen, so it is reduced. What is oxidized in the reaction? Actually carbon has been oxidized, not copper. Okay, carbon has been oxidized, not copper. So you can see over here we have sodium chloride. It has the zero oxidation state and it has become plus 1. So increase of oxidation state is oxidation. Okay, so sodium has been oxidized and sodium has lost an electron. It's okay. By losing electron, it's also called oxidation. Oxidation is the loss of electron, gain of oxygen, loss of hydrogen, loss of electrons, and increase of oxidation state. So both options are being seen. Okay, evidence is it is losing electrons. Okay, loss of electrons. So B is the correct option. Now let's see over here. Nitrogen has gained electrons. No, there is nothing gain or loss of electron. This is the covalent reaction. Okay, magnesium and zinc. Let me tell you about zinc. It was here +2 and it is 0. So it has not lost. It has gained electrons. So +2 to it becomes 0. So it is a reduction, not oxidation. Achha, let's say the question 24. Okay. So question number 25 we are going to start, which statement about the acid and base is correct. All strong acids. Which statement about the acids and bases is correct? All strong acids react with the carbonate, but not weak acid do. But all weak acids don't. All strong acids react with the carbonate. It's okay, but all weak acid do not. Weak acid do not react with the carbonate. It's not possible. Okay, weak acids also react with. Okay, the oxide of group 1 metals are amphoteric. No, the pH of 1 mole per dm cube ethanoic acid is higher than the pH of 1 mole of hydrogen. Yes, because ethanoic acid is C2H5. Okay, CH3COOH. Okay, that's 1 mole per dm cube. And second is H2SO4. It's also 1 mole per dm cube. Okay, this is strong. It will oxidize, it will dissolve fully, and it will give more H plus. Its pH will be less, it will be more acidic. Okay, and this is weak acid. Okay, it will dissociate partially and less H plus will be there, so its pH will be higher, means it will be less acidic. Okay, option C is correct. Some type of the chemical reactions are listed: acid base combustion reacts. Which type of the reaction occur in the blast furnace during the extraction of iron? The type of reaction which occur over there, acid base reaction. Second, combustion takes place. Okay, it's clear that combustion takes place over there. In which the iron oxide, okay, iron oxide reacts with the Fe2O3 reacts with the carbon, 3 carbon, and sorry, this is the redox type of redox reaction. This carbon monoxide formed is further oxidized. Okay, and this is also combustion. 3 carbon dioxide will be formed. Next. Okay, as it moves upward, so it takes 3. First, sorry, let me tell you, due to excess of 3 carbon, first is burnt. Okay, the carbon monoxide is formed, and then is further formed. It takes out the, sorry, first it takes out the oxygen, carbon monoxide is formed, then it further reacts with oxygen, then it is combustion. Okay, then carbon dioxide is formed. Acid base reaction also takes place over there. Where it takes place? Okay, let's see entire process. Sorry, 2 carbon reacts with oxygen, there is iron oxide Fe2O3 here, okay, and adding 3 carbon, so what will happen, 2 Fe will be formed and plus 3 carbon monoxide. So 3 carbon monoxide, when it moves upward, it will convert 3 carbon dioxide, okay. And how here acid base takes place, okay. 2 and 3 are confirmed. Yes, there happens actually one thing, that calcium carbonate is heated, so it forms calcium oxide plus carbon dioxide. This carbon dioxide reacts with the slag, you know that, sorry, calcium oxide. Calcium oxide reacts with the slag. So this is the base and this is the acid, and the calcium silicate is formed. Okay, this is acid base reaction. So all of these reactions take place over here. Okay, this is the redox, this is the combustion, and this is the acid base. Which method should be used to make a pure sample of potassium chloride? KCl AgNO3. This will be aqueous, and KCl will also be aqueous. K2CO3, NaNO3 will be aqueous. KCl. Okay, KCl plus H2O. Yes, we have this option. This is the correct option. Okay, means we have to use the fixed amount of the titrating this base with the acid. Okay, when we have KNO3 and we add AgCl, so KCl will definitely be produced, but AgNO3 will also be produced. Okay, so to differentiate is very hard, both are soluble. Okay, and excess K2CO3 and plus HCl, so KCl will be formed and water will be there. Okay, and then carbon dioxide will be formed, which will be released. So there are actually 3 products. Okay, we are using excess of this, so when we use excess of this, so it will also be left, so there will be impurities. Mixing KNO3 with NaCl, so KCl and NaNO3 will be formed. Okay, but you must know that NaNO3 will be soluble and KCl, so actually it will be the aqueous solution of both of sodium nitrate and potassium chloride, so separating them is very hard. So but when we take titration of these, so KCl will be formed with the water, so we use the fixed amount of the base from the burette, and the fixed amount of the HCl has been taken in the conical flask. When the titration is done, so there will be water. Okay, so we just evaporating, water will be removed, there is no any other compound. Okay, so water will be evaporated, so it will be aqueous solution of, yes, pure sample aqueous solution of KCl it will be. So option D is correct. Question number 28. A pure sample of lead sulfate is made by reacting the aqueous solution of 2 salts. The lead sulfate formed is then separated by the mixture from the mixer. You must know that lead sulfate is insoluble. Okay. Okay. Base solution and the method of separate are used: lead chloride and sodium sulfate. What will happen over here? When you use lead chloride, okay, PbCl2, and you use sodium sulfate Na2SO4, okay, you will find PbSO4 plus 2NaCl. Okay, so it will be insoluble and it will be soluble, so method of separation is not crystallization. Method of it has to be filtration. Okay, lead chloride, sodium sulfate, sodium chloride, it will also form aqueous. Okay, so and this will be insoluble. Okay, lead chloride, PbCl2, and sodium chloride, which solutions and method of separation are okay. So aqueous and lead sulfate okay. Lead chloride and sodium sulfate. Lead chloride and sodium sulfate and lead sulfate will be found and sodium chloride will be there by filtration directly. Let's see other methods. Lead nitrate and potassium sulfate. K2SO4 will get to the PbSO4. It's okay, but 2KNO3 it's mixture of both, so by crystallization this is also not possible. Lead nitrate PbNO3 twice plus potassium sulfate K2SO4. What will you get? PbSO4 plus 2KNO3. Okay, this is solid, and lead nitrate, potassium sulfate. This seems correct option, okay, because lead nitrate and potassium sulfate both will react. So lead sulfate will be found which will be solid and potassium nitrate which will be aqueous. So by filtration we will get lead sulfate, okay. So this is the aqueous solution, okay, of two salts. Actually lead chloride is not aqueous solution, that's why, otherwise it seems correct, but it's not aqueous solution. Okay, you know that lead chloride, HgCl and AgCl, these are insoluble, okay, you know that, so that's why it is not aqueous solution, okay. So we have been given that solution of two salts, aqueous solution of two salts, so this is aqueous and this is also aqueous, okay. So option D is correct. Which statement is correct? Food can be preserved by using the sulfur dioxide. Yes. In contact process, oxygen reacts with the sulfur to form the sulfur trioxide. No. It forms sulfur dioxide and then sulfur dioxide further reacts with oxygen to form sulfur trioxide, okay. Sulfur dioxide is used to kill the bacteria. Wood pulp, no. Sulfuric acid is used as bleach, not at all. Chlorine is used as bleach. Element Y is in the period table. In the period 3 of the period table, it found a chloride that is liquid at room temperature. Okay, which row shows the correct information about the group number of the nature of the oxide of the element Y? Group 1, the chloride, okay, let me tell you, chloride of group 1 are basic, but it's saying that it is liquid at room temperature. It's not possible. And group 2 are also basic, okay, but not liquid at room temperature. Group 4, group 4 are covalent, okay, and amphoteric, okay. And group 6 suppose oxygen and sulfur chloride, okay, OC T2, okay. So OCl or SCl2. Group 3 has been, it is found the it found the chloride that is liquid at room temperature. Here is because they have the weak intermolecular forces, okay, so and acidic in nature, okay, and oxide of these elements form the nature of oxide. Nature of oxide is this is not nature of oxide. Nature of oxide is acidic, okay. Okay, liquid and acidic, okay. Let me group number. First group, these are solid, so that's why it doesn't fit. It found the chloride that is liquid at room temperature. solid, solid, solid. Here its nature is correct, it's not correct. Okay, this is also not correct. So from here, but here sixth, its chloride is a liquid. Okay, and its oxides are acetic. Which gases are used in the light bulbs? Argon, oxygen, neon. So in here you know that which gases are used. Argon is also used, and neon also. Oxygen can never be used. Okay, so 1 and 3 only. The coordinates of metal W, X and Y are heated and results are shown. Okay, so we have question 32. The coordinates of metal W, X and Y are heated and results are shown. So W is white, the color of metal carbonate, white, green and white. Okay, so you will see that given gas, gas given off which turns the lime water milky. So it means these both have been decomposed. Okay, so the remaining, you know that when the metal carbonate is whether in metal X, I'm writing here. So metal oxide is formed and the carbon dioxide is formed. So means metal oxide is yellow when hot and white when cold. So it's okay, but it's black. So metal oxide which is black, it is it seems this can be the copper oxide. Okay, as it is being told over here in the next. So experiment results can be used to write the statement W, X and Y. The carbonates are W and X gave off the carbon dioxide on heating. It's okay. W and X, they gave off the carbon dioxide on heating. It's okay. Metal X and Y are less reactive than metal W. X and Y are less reactive than W. No, only Y is less reactive than both of these. Okay, this is not correct. So X could be copper. This can be copper because the black oxide which is remaining is of copper. So it could be the, now here the color is green, copper carbonate. Okay, you know that copper has green color, so it could be copper. It's okay. 1 and 3 are correct. The diagram shows an experiment to determine the percentage of the air in the oxygen in the air. So we have the candle which we light. Okay, lit candle means it's burning. Okay, and we have the bell jar which contains the 21% oxygen. Okay, and this is the water. What will happen? Water level will decrease, will remain as it is, will increase. Actually, it has 21% oxygen. When that 21% oxygen has been used, so you can say that gap is produced, a vacuum is produced, due to which this water rises upward. So does not decrease, does not remain as it increases. Okay, but how much it increases? It is 50% showing, and it is showing almost 20%, 20, 40, 60, 80, 100, like this. Okay, so this seems a bit correct, and this you can say that it has 40 or 45%, even you can say 50%, but it's not possible. It doesn't have the 50% oxygen. Okay, that means it contains 20% oxygen, so that 20% when it has been used, so the water level increased. Okay, option C is correct. The two statements are given. The percentage of carbon by mass is greater in the methane than in butane. Okay, mass of methane is 16 and butane C4H10. So 12 fours are 48 plus 10, it becomes 58. Okay, so 48 divided by 58 multiplied by 100, and this is 12 for one carbon divided by 16 multiplied by 100. Okay, so the answers for this is 12 divided by 16, this is 75%, okay, and this is the 48 divided by 58, this is 82%. So in carbon there is no more in the methane there is no more carbon percentage, in butane there is more, so this is incorrect. Butane is one of the two isomer with the molecular formula, it's okay, molecular formula is correct. So both statements are, which statement are correct? Both are correct? No. Statement 1 is correct, 1 is incorrect. Statement 2 is correct, yes, 2 is correct. Neither statement 1 nor 2, no, it's not possible. This is correct and this is incorrect. The 1 mole of each of the compounds shown is completely combustion. How many of the compounds need exactly 9 moles of oxygen for the complete combustion? How many of compounds? Okay, so 2 moles we can say, or 1 mole, or 3 moles, or 4 moles. How many of compounds need exactly 9 mole of oxygen for complete combustion? Okay, let me write one by one their combustion, okay, so that we'll have the clear idea. C5H12O plus oxygen. Now let's see, 5 carbon dioxide plus 6H2O. 5 twos are 5 twos are 10 and 6 ones are 6. 10 plus 6 is 16. 1 is here, so it becomes 15 is remaining, 7.5. I'm right here. Next is C6H12 plus O2, so 6 CO2 so 6H2 is formed. So how many? 6 twos are 12 and 6 ones are 6, so 18, so 9 O2. Okay, now let me see one more, C6H14 plus O2, so what is formed? 6 CO2 plus 7H2O, so 7 ones are 7 and 6 twos are, so 12 plus 7 19, so 9.5. C6H14O plus O2 give rise to 6 CO2 plus 7H2O. Now let's see, 6 twos are 6, 7 ones are 7, and 19, 1 is here, and 9 twos are 18, 18 plus 1 19. So this compound requires 9 mole and this also compound requires 9 mole, so B option is correct. Okay, other require 7.5 moles of oxygen and 9.5 moles of oxygen. Okay, so the reactants and products of two reactions are shown. Okay, so you will see that a reaction is going to take place over here. Actually this is the propene, okay, CH3CS double bond CH2 like this, and the water reaction with the water is a hydration. Okay, so what will happen, something like X is the CH3 CH and OH and CH3 like this will be formed. Okay, so this is the propanol, this is not butanol, there is no addition of carbon, there is just same three number of carbons. Okay, just addition of water is there, and this alkene converted into the alcohol. Okay, yes, so they need heat and they need of course heat and catalyst. It's okay for both the same options. Okay, next, what happens over here, the reaction with the oxygen is the combustion when the carbon dioxide and water is produced, so option D is correct. Okay, this is not decomposition, it's also incorrect. Which statement about the carboxylic acid is correct? All carboxylic acid include this group. It's okay, this is confirmed, so we don't need to move towards others. The structure of ester is shown. Okay, so which is the name of the ester? let's split from here. This is the propyl and this is the 4 butanoate. Propyl butanoate, option C is correct. Okay, because propyl comes from propyl alcohol or propanol. Okay, so that's a propyl, and which comes from carboxylic acid. Okay, its name O8, one given, so butanoate, 4 butane. Okay, butanoate. Polyethylene is formed by the additional polymerization. Nylon and terylene are example of condensational polymerization. Condensation addition, this becomes incorrect. Okay, this is going right. Protein contains the same amide linkages, not ester linkages. This is incorrect. Fat contains the same ester linkages. It's okay. Fat contains ester linkages. It's okay. Anhydrous is a protein from amino acid, not simple sugars. Okay, so option A is correct. Protein is the building blocks of amino acid is the building block of proteins. Okay, the repeat unit of polymer is shown. So hydrogen, it's okay. There's a chlorine and bromine. Chlorine, bromine. Okay, uh, chlorine, bromine. Chlorine, bromine on the same side is impossible. These are opposite sides. Okay, chlorine, bromine on the same side is impossible because these are opposite sides. Okay, but like this is also not possible. Okay, option A is correct. Just we have to convert into double bond. Okay, single bond to double bond. So option A is correct. Thanks for watching this video. For more information you may contact on WhatsApp. Okay.